So I'm going to start this now. Welcome to PASS. Welcome to this presentation, Packaging Permissions in Store Procedures. And yes, first a reminder, if you have a cell phone, you don't want everyone else in this room to hear the ringtone, and particularly no one else want to hear it. So if you want to take a call, you need to take a call, you might have to. That's okay, but just leave the room, but make sure your phone is on silent. That makes it so much better for everyone else. PASS has a few more things to offer than besides exactly this summit. And there is something quite interesting connection between the summit and the things you see on this slide. So to come here, you or your boss had to pay quite a stiff fee for the conference, but quite a bit of that money goes back to the community and all these things you see here, because all these things are free. I'm not going to talk about all of these, but we have 24 hours of PASS, so they are webinars, they run around the clock a few times a year. You can go to a local user group meeting in your area, listen to some presentation about SQL, net with local people, maybe find a new job, just find interesting thing what people are doing. And my favorite here is SQL Saturday, which is a free one-day training event that takes, well, it's about every Saturday somewhere on the globe. It's usually, SQL Saturday is taking place. Sometimes, I don't know what the record might be, but there could be 2-3 in Europe, a couple in the States, and a few more in other places. I mean, the one reason I like them is I speak like, I think it's going to be 10 SQL Saturdays this year. And for those that are in the bottom row, I'm going to leave that to other presenters to discuss. But so yes, PASS has a whole more things than this summit, and the rest of this is free. If you have to be a member of PASS, but that's also free. So who am I then? Well, my name is Erland Sommarskog. I live in Stockholm, where I work as an independent consultant. I've been an MVP for SQL Server for, well, many years now. You can have here's my email address down here. If you want to reach me after this presentation, please feel free to contact me. The address is sql@sommarskog.se, or as my friend Anthony would say, SQL, because that's actually a city in Argentina with that name. And I have a website, sommarskog.se, which you can say is a small collection of large articles that goes in depth in a couple of topics. And one of these articles is actually called Packaging Permissions in Store Procedures. And this talk is, well, it's a condensed version of that article to get you started and interested in the topic. So what is this all about? Well, let's say this. You have a database, or you have a server, and you have a user. Is anyone here who does not have a user? I don't think so. And we want this user to be able to perform a specific action, X. And this X, well, a permission X. And that could be select on a single table, or it could be, well, sysadmin, or anything in between. But we don't want to grant that user the permission directly, because then the user will be able to do a lot more that we don't want him to do. We only want him to see, let's say, from the employees table, employees from its own department, not all employees. Or, well, if he has sysadmin, it might be for one very specific thing, not taking over the entire machine. And the same applies to a lot of other things. So what if we could package that permission inside the procedure that performs this action, so the user can do exactly this, but nothing else? Wouldn't that be great? Oh, wait a minute, isn't that the way it works? Some might say. Nah, not really. There is a very special common case where this works out of the box, so to speak, but not in the general case. But what we're going to learn today is exactly that, how we can do that in all the other cases by employing some extra techniques. So here is the short agenda for what I will talk about. I will start to talk about ownership chaining, which is that very special but also very common case. I will talk about certificate signing, which is the prime method to use when ownership chaining doesn't work. I will talk about using the execute as clause, which is, well, you can achieve the same thing, but in my opinion, it's maybe not so good for reasons that will prevail. That will also lead us to talking about the dangers of making a database trustworthy. And at the end, I will make a very, very quick survey of how applying these techniques for cross-database access. So ownership, also, yes, should point this out. At some point, I will go fairly quick. But if you feel that, I want to take a photo of this, I want to see this, no problem, no panic. The slides and the scripts, they are available on the PASS website. They're also available on my website, sommarskog.se/present. So you can download all the slides and the scripts are really designed for you to download, so you can play them and study this technique in more detail if they interest you. And they should do, because I think they're useful. So, ownership chaining. This has been in the product since, well, as long as I've been working with it, and it probably was there even in the 80s. So, this is where it works. Let's say you have a procedure, or it could be a view or a function, etc. And it makes an access to some other object, a table, a view, store procedure, etc. And these two objects have the same owner. SQL Server will not check any permissions at all. And this applies for, well, plain, simple DML, like select, insert, update, delete, and merge. It also applies if you invoke another store procedure or function or a trigger, etc. But it does not apply if the access is through dynamic SQL. It does not apply if you go and query metadata about the object. And it does not apply if the operation requires special permissions, such as alter. So let's have a look at this. Here, so I'm going to start this with creating a database called PermTest. And I will make SA the owner of PermTest. Now, I'd like to point out this from the start. That is not best practice. And why it is not best practice, I will return to. But for right now, SA is going to own this database. The next thing I will do is I will create a login for a test user. It's called test user, and the password is obladi oblada. I'm going to move over to PermTest, where I will create a database user for test user. I will create a role, rock and roll, and I will make test user a member of rock and roll. And the next thing I will do is I will create a view called token info. I will use this for diagnostic purposes. It retrieves 3 columns from this view called sysuser token. It's a sort of a DMV, but everyone can access it, and has 3 things here. And when you see the data, it's easy to describe what I'm talking about. It also returns the system function's original login, the one who actually logged into the server, the current system user, the current login on the server level, and user, the current user on database level. This is a little conflict. And the correct terminology is for server principle is logins in SQL Server and users on database level, which you easily can confuse if you don't think about it. Well, anyway, next thing I will do is I will create a perm table, or I create a test table called perm table. It has 3 columns. There is an ID, there is a title, and there is an auditing column called entered by, with the default of user. And I'm adding 1 row to this table with the title strawberry fields forever. Now, next thing I will do is I will create a procedure called test SP, which takes 2 parameters, an ID and the title. It returns all the data from token info, inserts a row into perm table, and select everything there is in perm table at the moment. And then I give rock and roll the permission to run test SP. So far I've done the setup, and you might now observe no one has permission on perm table. No permission has been granted on perm table. Now what I'm going to do is I'm going to play test user. And you might think that, okay, then I need to log in with a second query window, entering that password to be test user. I don't have to do that. I can use this command, execute as user, to impersonate test user. And I will be test user until I execute this command, revert. Now, I would like to give you a tip here. When you use this revert command, always put that in a batch of its own. There's no need to for the syntax. But the problem is, let's say you get an error when running this, and you don't have it revert in a separate batch. Well, maybe that error aborts execution of the batch, so the revert is never executed, and your remaining test user, then you will be confused because you think you're yourself. I know that because it has happened to me. I learned this the hard way. So I will be test user now, and test user is going to enter new title, fixing a hole. And you can see, despite the fact that test user does not have any permission on perm table, he could insert a row and he could select all the data. And you see, fixing a hole was entered by test user, strawberry fields forever was entered by me, DBO. And here we can look at the tokens, or the information from the token info. So the token itself, there are 3 of them. There's test user, which is test user itself, and SQL user. That is public, and rock and roll 2 server roles, 2 database roles. And we also have a usage, grant or deny. So this token is good for both grant and deny. So these tokens are the one that contributes with permissions. And the total effective permissions are, well, the result of all these permissions. And we can also see the original login, that was me, that's my ID. But the current user that I'm impersonating is test user. So now what I'm going to do is I'm going to change the owner of perm table to a different owner. because I only need this user for this special thing inside the database. I don't bother to create a login. So I say create user without login. That's also one handy thing when you're testing permissions. If you want to, let's say you set up a role, then you want to test permissions, how do they work? You can create a user without login in that database, drop it at the end, but then use that to play with. So this time I'm going to use this to make different owner, the owner perm table. And now test user tries to run this and tries to enter me, Mr. Mustard. And, oh, I get the insert permission was denied. The select permission was denied. I should also go back to the tokens, just like to point out one thing. So test user was able to run test_sp because this guy here has execute. So this guy is contributing with that permission to run it. Now, in most databases, everything is owned by DBO. It is not always the best idea to do, but if you want to keep things simple, well, and you don't change anything, everything will be owned by DBO. And that is the case we will work with. So I'm going to change that back, and test user is going to make a second attempt with main Mr. Mustard, and now it succeeds. Because when default owner owned the table, SQL Server said, okay, we need to have permissions. And no one had permissions. So that's why it failed then. But now there is no permission check being performed. So that is the power, how we can package simple permissions like select in a stored procedure. And we have probably have done this lots of times without even thinking of the mechanism. Now let's see what happens if we change the procedure and try some variations. So I'm going to change the test_sp by adding a dynamic part. And there is some dynamic SQL there. Some bad dynamic SQL. You can see this. This is wide open to SQL injection. An evil user could enter something that starts with a single quote in the SQL command and 2 dashes at the end. And that command could run. And depending on the permissions, bad things could happen. So test user tries to run this, and he's a good guy today, so he would enters love me do. And you see the dynamic part, the select permission was denied on object perm table. But you can see love me do was inserted. So why does the dynamic part fails? Well, so this code here is not part of test_sp. It might seem so when you look at it from with your eyes, but as a matter of fact, this is a separate stored procedure. It doesn't have a name, and it doesn't really have an owner, or you could say test user is an owner. Whatever, there is no ownership chaining here. So for this to work, the explicit select permission has to be present somewhere. And this is actually a feature, because imagine that ownership chaining had applied here. Well, then a malicious user could enter, let's say, well, single quote, delete, complete a different table, or select complete a different table, and get access to data he should not be able to access. So that's actually a good thing. They're stopping this. Here's another variation. I'm adding a new parameter called reset. And if reset is 1, well, that permits the user to delete all data in the perm table and start over. But to be efficient, I'm using the command truncate table. So I'm doing this change here, and test user tries to run this and enter Martha, my dear. There's an error message. Can't find the object perm table because this does not exist, or you do not have permission. And that's on line 5. And line 5 is 1, 2, 3, 4, 5, truncate table. Because although logically this command is a delete command, it is actually it requires alter permissions. Why? Well, it has always been that way. So that didn't work out, because for alter permission, ownership chaining does not apply. So here, in this case, SQL Server is actually checking the permission. Saying, no, the user needs that permission to do this. So that's the limitation of ownership chaining. And here's another thing that can trip us. We're thinking that, in this case, we're looking at metadata, because we think that we have some deployment problems here. Maybe perm table does not exist when the user is running this procedure. So we're going to add a check saying, hey, yeah, we don't want an ugly error message being splashed in the face. So we check if the table exists, and if it doesn't, we're just going to say more sort of silent, more civilized, no table today. So we try this, create it this way. And test user tries to run this and tries to enter the fool on the hill. And sure enough, he feels like the fool when it says no table today. I was able to insert data into that table just a few minutes ago. What happened? Well, the problem is this. To have any access to metadata, be that through system functions like object ID or through access through catalog views, the permission, at least view definition, has to be present. SQL Server will always perform a permission check in this case. So, and this is something that can easily be you can easily walk into this trap. So we have now seen when ownership chaining works and when it does not. Now we're going to look at what we can do in the cases it does not work for us. So, and the main prime method of this is certificate signing. And I will start off just giving the recipe to do this, and then I will explain the steps behind it. But the recipe is this, it's 4 steps. You create a certificate, and you sign the procedure with the certificate. You create a user from the certificate, and then you grant the user the permissions needed. And that could also be membership in role. Now, that sounds like a quick thing, but wait a minute, what is this all about? So I'm going to try to explain this. First of all, certificates and signatures, that is nothing which is unique to this thing. But rather, certificates and signatures is something which is quite commonly used in the world of IT security. So a certificate, that's an asymmetric key that has 3 components. There is a private key that you keep secret and protect with a password locked in the safe or whatever. There is also a public key that you can share with anyone. There's nothing secret about that one. And there's also some metadata of actually also signature on the certificate itself to prove that the certificate is valid. Now, for our purposes, we're going to work with self-signed certificates, and we're not going to touch these metadata very much, but I just like to point that out. So how does this whole thing work? So you can sign with a document, a PDF, or an email, whatever, with your private key, using your password or whatever you have to protect it. Now, someone who then receives that document, email, etc., can take your public key, use some cryptographic functions, and say, was this document, key, mail, etc., signed with the corresponding private key? And if the answer is yes, this means that the document was from you and it has not been tampered with in transport. So it's a way to establish trust. Now, what has this to do with SQL Server and stored procedures? So, if you start a stored procedure, you invoke it, SQL Server will check, is the signature signed? In that case, is the signature still valid? And if it is, well, then SQL Server will see, is there a user associated with this certificate? Yeah, there is. Now, what happens is that the SQL Server will add that user to sys.user token, which means that the permissions of this user will apply inside the stored procedure. This may not register right away the power of it, but we're going to see that in a few seconds. Just going to do some quick more things about this user. It's a special type of user. You cannot log in as this user. You cannot impersonate it. It's called the user because, well, that is the terminology in SQL Server for historic reasons. It's a database principle. And also, you can only create 1 user per certificate. So let's have a look at this. So I'm going to move over to perm test. I'm going to create a certificate called DemoCert. I have to give a password, which I say is all you need is love. No, I don't have to give a password. I have to specify how the certificate is protected. I can protect it with another key. I can protect it by the database master key. Maybe there's more variations. It doesn't matter. For this purpose, we always use passwords. And I also have to give a subject. This is required by the syntax. And it's, well, a real subject has, if you look in the certificate registry of your laptop, you might find some syntax with semicolons, but you can put in any free text here, or almost any free text. You can't have a comma. So I have just set in certificate to demonstrate procedure signing. But if you put in a comma, you will get a syntax error. It made me very confused when I ran into this. So the next thing, I'm going to sign the procedure, and this is the command add signature to TestSP by certificate DemoCert with password. All you need is love. Because I'm using the private key, I need to specify the password to access it. Before I go on, so here is a query so we can use to see which procedures in our database that have been signed. So there is a catalog view called sys.crypt.properties, and I joined that to sys certificates to get the name, and I'm joined that on the thumbprint column. The thumbprint is, I think it's 32 bytes, something like that, which actually uniquely identifies the certificate globally. And then I also joined to sys objects and sys schemas to get the name of the procedure. So I can see here, run this, and I see that test.p has been signed by DMACert. I also included the subject. And here is the data from sys.crypt properties. And out here is the signature itself. Well, it's a blob, so it's not very thrilling to look at. So then we move to the third step in the recipe, creating the user. And I say create user, DMACert user, from certificate DMACert. So I do this, and if I try to create a second one, just add a new name here in the middle, you see I get an error message. Oops, I should have pressed that one. So, Control Z. Okay, so then we can look at this guy in Sys database principles. So here is the DMACert user, and you can see it's type C, it's certificate mapped user, so it's a special type, and you see authentication type desk is none, so yes, you cannot log in as this guy. And finally then I need to, well, decide on some permission to grant to this user. In this case, for this demo, I'm going to use select on perm table. So, go back to our test.p, and this is how it looks right now. We have this metadata check. We're going to check if perm table exists. Well, then we're going to insert row, or else we're going to say no table today. And last time we tried this failed. So, test user is now going to make a second attempt, a new attempt, and you're going to try this time to enter across the universe. And you see, this time he was able to insert the row and get data back. And now we can see among the tokens, DMACert user map to certificate. And because this guy has select permission on perm table, now the test on object ID succeeds. So that's what I said, that because the token was added, the user was added to the tokens, we also added the permissions. So this is the entire, or the core of the whole thing of putting the permissions or packaging it into the store procedure. Now let's try this for we'll look at some variations here. Well, yeah, so the first thing we're going to do is we're going to use this complaint about this message here, no table today. It's a little cryptic, so we're going to change this text to say perm table has not been created yet. So I'm going to do this, I'm going to change the procedure. And test user is going to try to run this to enter here comes the sun. Now, before I do this, do you think this was going to succeed or not? Nah, why? No, perm table has not been created yet. Remember what I said. The point of the signature is to verify that the contents has not been altered. And we altered the contents. So the signature can no longer be valid. And therefore, we can also see this among the tokens. The certificate use is no longer there. As a matter of fact, SQL Server takes this one step further and realizes, since we changed the procedure, that it doesn't even bother to keep the signature, just throws it away. So we need to sign it again. And now, test user can run this and enter, here comes the sun. And then see now that the certificate user is back among the tokens. Now we're going to try some variations of this procedure. So we'll see if we can use this for the dynamic SQL. So this is again the version with the dynamic part and the bad dynamic SQL. So I'm creating that one, I'm signing it so the certificate has some effect. And test user runs this to enter taxman. And yes, you see now, no error message, he did get back data from that second select, or the third select, which just returns the title that was inserted. And you see here, well, the DMACert user is present. And obviously, when we entered the dynamic SQL, this token was still present, so the select permission was available. Now, again, this is still open for SQL injection, but the only thing this could be exploited for now is to get more back data from perm table than the user is permitted to see. That could definitely be bad enough if the data is sensitive, but at least the damage is limited. Now I'm going to study this further, how this token, how this extends when we enter other modules. So I'm going to create a trigger on perm table, and all I'm going to do is I'm going to return the information from token info and the name of the trigger. And likewise, I'm going to enter an inner procedure, and again, just returning the name and the information in token info. And then I'm going to create this version of the procedure where I return the information in token info. I call SP help index, a system procedure on the table. I call the inner P. I insert the row into the table, that will fire the trigger, and then I also the general select. Before I sign it, let's just study the effect on the system procedure. So test user runs this and enters revolution number 9. And you see here I got an error message from SP help index. So obviously no ownership chaining applied there, but there has to be a permission present. But the rest here you can see there was, well, there are 3 rows there, 3 rows there, and 3 rows there. And down here, revolution number 9 was inserted. So let's now sign it. And test user runs this now to enter helter skelter. And so yes, the certificate user is back here. SP help index worked. So obviously, again, this token of DemoCert user was present when we ran SP help index. But now look here, in inner SP, there are 1, 2, there are only 3 rows. Same thing for the trigger, there are only 3 rows. So that is, when we enter user-written code, SQL Server actually removed the token from this user token. And this is actually quite smart, because when we enter dynamic SQL, system procedures, that is things we cannot sign. So yeah, it sticks the token there. But for these two, here we have the option. If you want the permissions of the certificate to apply here, we need to sign them as well. And this is can be quite a good thing. Let's say that inner SP is also intended to be called on its own, but it also, for some reason, performs some explicit permission check. Does this user have the permission to do this? It's not going to be tricked because some higher level procedure someone signed it for some other reason. So before I close this, I'm just going to drop the trigger and go back to the slides. So, yeah, just summarize what we've seen. So every time you change the procedure, you have to sign it again. And we're going to talk this in a second, how to deal with that. Also, again, the token and the permissions of the certificate user is brought on into dynamic SQL and to system procedures, but not into user-written code where you have the choice to sign yourself. So you might now think that, yeah, this sounds interesting, but hey, all these passwords, yes, just sign again and again, it's just impractical to use. No, no, no. What do you do when you have things like that? You automate it. And I've done this for you. So in the download material, you find a procedure called grant perms to SP, which implements this recipe. So it takes 2 parameters, the name of the procedure to sign, and a table value parameter with the permissions you want to package with that procedure. So what it will do then, it will create a certificate, and the name of the certificate will be formed from the name of the procedure, so you can easily put them together. The password, well, that will be a random GUID. Because you will actually, for reasons that will prevail just shortly, you will never need to know this password. And the subject, well, for documentation purposes, that is just the permissions to be granted. So you can easily look and see certificates and say, okay, that certificate goes to that procedure, and those are the permissions I package with it. So then it goes on signing the procedure with the certificate and creates a user from the certificate. And again, that name is formed from the name of the procedure, and then grants the certificate user the permissions in the TVP. Now, if you rerun the procedure, maybe with different permissions or whatever, it will drop everything. If there is a signature, it's dropped. If there is a user, it is dropped. If there is a certificate, it is dropped. And then it will start over, creating a new certificate with the same name, but it's a new certificate because it will have a different thumbprint. And here is an example of how to run it. So I have a table type, and I have a separate schema for this, because I think it's quite practical in the database to grant execute permissions on the DBL schema. I guess many want to do that because then you don't have to grant on each individual procedure. But obviously users have no reason to run this procedure, so those things like this should be in a separate schema, which I have called management. So I got a table type called permission list. I was inserting one row into my table variable and pass this one to grant perms SP, the name of the procedure, the permissions, and yes, there's a third parameter, debug, because this procedure does a whole lot of dynamic SQL, and when you work with dynamic SQL, you should always have a debug parameter. Always, always, always. So you can see what is being generated. Not the least because you really encourage you to do that. If you feel that, oh, I want to do this in a different way, you can take this code and adapt it to your needs. And then it's great to have a debug so you can see what you actually generated. And in many cases, what you would do, you would put a call like this in your deployment scripts. So you just have create your procedure there, go, and then you have these 3 lines at the end. But you could do it differently. Let's say you have junior developers. You don't want them to be able to do this, so they just write the procedure, maybe deploy it in some way, and then afterwards you can sign it after having reviewed the code to see that it's okay. And very important principle, it may be actually the most difficult part of it all that I'm not going to talk a whole lot about how to do, but you should always identify the minimum permission you need to package with the procedure. You can always make it simple by just saying, well, the DB owner here, because if it's a role, it's going to see that it's a role and add you to that role. But don't do that. Make the effort of finding exactly the permissions needed for the task. Because if there is an SQL injection hole, well, then the damage will be limited. And of course, you're reviewing the code, so you know that there is no SQL injection hole. But then someone, like 2 years from now, some junior guys comes in and changing and does the dynamic SQL the wrong way. Yeah. So don't change this thing at the bottom because he doesn't understand it anyway. So let's have a look at this procedure. So I'm going to first move to perm test, and I'm going to change this to the truncate version. Back to that one. Going to use that one. And here I'm creating the management schema. Here is the table type. It's just a one-column table. And here comes the procedure. And I'm not going to go through the procedure as such because that's an exercise in dynamic SQL, which is not the topic for this presentation. But you're certainly encouraged to look at this procedure later, when you download it. I think it's a good piece of dynamic SQL, but that's me. So, oops, went too far. And so here I'm setting it up, and I think I need delete permission because we need to delete all data. It wasn't that way. Let's see. I'm going to do this, create the certificate, test_p, $search, that's the pattern. The dollar characters, if you think that's nothing special. That's just another, that could be an underscore or anything else. Just use that as an indication, adding that to the procedure name. And $cert. Encryption my password, you see, is a grid with subject, grant, delete, and perm table. Add signature to dbout test_p by certificate with password, etc. Create the user from certificate, and then grant the permission. And test user tries to run this, tries to enter paperback writer, but oops, this fails because, oh yeah, yeah, it was the wrong permission, of course, and it's alter permission that I need, not delete. But the purpose of doing that mistake is that then we can see what happens on rerun. You see, it does drop signature from dbout test_p, drop user, drop certificate, and does this all again. And now test user can try to run this, and the whole thing works. So you see, the table is clear, there is only paperback writer, because this guy has alter permission. So far, I talked about doing this on database level. Let's now take it to the server level. So we can employ it there as well. And I'm going to start with introducing a scenario. So let's say we have a multi-application instance, and we have lots of databases on this instance, and you are the server-level DBA. And for each database, there are power users, which has DB owner permissions, but no server-level permissions at all. They shouldn't have. And these people, they have a legit need to see which users that are connected to their database. For instance, they want to see, currently, right now, no one is connected. I can do some maintenance work, for example. And to be able to see that, they would need the permission of view server state. But then they could see too much. They could see query plans, potentially query statements, and potentially then see sensitive data. Or they could just see all users on the system. Just imagining this is a hosting service, so they can see users or logins from other customers. Completely unacceptable. So this is when certificates come to the rescue. So here's the recipe when the procedure then you have is in the master database. Then it's very similar to the database case. We create the certificate, obviously in master. We sign the procedure with a certificate, and we create a login from that certificate, and grant the login the required permissions. And we have to work with a login since it's a server principal we need. A login and a server principal is the same thing. But while it's called a login, it cannot log in because it's really a server principal. It exists only again to connect the permissions and the certificate. That is, when the procedure has a valid signature, SQL Server is going to add the login to syslogin token, which is the corresponding to sysuser token, and the permissions of the certificate login will apply. So let's look at this. So I'm going to start moving to master. I'm going to create a role called a server role called super users. And I'm going to create a user called perm_test_super with the password of yesterday, and I'm going to make that guy a member of super users. So the super users are people that the DBO has recognized has the right to see which users are connected to the current database. And I'm going to create a view called login token info. This is the same thing as before, except that I'm now using sys login token than sys user token, but apart from that, it's the same thing. And then I'm going to create a procedure in the master database, and it's called sb_show users in DB. And because it has a name sb_ it can be invoked from any database, and it will execute in the context of the database it was invoked from. Yes, so that is your own system procedure. Now beware, this is not documented, this is not supported, it could break at any time. Particularly Microsoft could ship their own procedure with the same name. But I'm going to do this anyway, and I'm going to start with returning the information in login token info. Then I'm going to check, is the current user a member of superuser, or does it has the permission controlled server? That is it sysadmin? In that case, I'm going to run this query, select star from sysdmxx sessions where database ID is equal to the current database. And if not, I will give a permission error. Now, it may seem a little odd to do the permission check inside the procedure. Wouldn't it be better just to grant permissions to the super users directly? Now, here's the problem. You grant permissions on store procedures to database principles, not server principles. So you would need to add users to master to do this. Do you want to do that? I don't. There is only one principle in master we can grant permissions to, really, public. So that's why the permission check is inside the procedure. I'm going to move over to perm test, and I'm going to first run this as myself. And we can see, here you can see my tokens. I've got lots of tokens. I collect tokens. I love tokens. Yeah, and more seriously, if you have a Windows login, you will always get a bunch of tokens from all the AD groups you're a member of. I think when I do this with my client, I get that something like 50. Right. So anyway, more interesting here, you can see there are 4 rows. If you look closely, I got 5 tabs open, but this tab here is in temp to be. So that I only see the other 4. So that's only see the sessions connected to perm test. Now, I'm going to try this as perm_test_super. I'm first going to create a user for him in this database, and I'm going to add him to DB owner in this database because, well, he's a power user, he's a super user. And then I'm going to play perm_test_super, and I'm going to change the command to execute as login. This is also very important. When you're playing with server level permissions or cross database, you should always use execute as login. As a matter of fact, you should only really use execute as user when you impersonate a user without login, because execute as user have some permissions, have some restrictions that can confuse you, which you don't have with execute as login. But since I like this idea of creating users without login, I use that in the first demo. So anyway, I'm going to play perm_test_super. He runs the procedure, but he only sees his own session because that is all you get to see when you don't have view server state from this DMV, which is more than you can see from most other DMVs. For many other DMVs, you only get permission error. And you can also see the tokens, perm_test_super, SQL login, and public, and super uses the server rows and grant or deny. So now let's fix this with certificates. I'm going to move to master. I'm going to create a certificate called demo server cert. The password this time is while my guitar gently weeps, and with the subject for the signing of the procedure sb_show users in DB. I'm going to sign the procedure, add signature to sb_show users in DB by certificate demo server cert with password while my guitar gently weeps. I will go on creating a login with demo server cert login from certificate demo server cert. And just going to show same thing here. I can only create one login. If I try to create a second one, I get an error. And I can look at this login in server principles. And you can see it is a certificate map login right up here. And you can see actually there are a few more that comes with SQL Server itself, which they use for some purpose. And then I grant this guy view server state because that's the permission I need. So I move over to perm test again. And perm_test_super is going to try to run this procedure again. And now you see the whole thing works. And we can see here, among the tokens, there are also demo server cert login and daemon server cert the certificate as well. But it's this guy that has view server state. What the point with the certificate is, I don't know. You can't grant permissions to two certificates. So that's why they have this login and this user, but for some reason it appears. So, but it might be the case that you don't want to stick the procedure into master. You want to have this in the user database. For example, a prime example of that would be bulk insert, because bulk insert requires server level permission. So you would have to do something like that to arrange with it. But I'm going to stick with the view server state example though. So anyway, the recipe changes a little bit here. So, sorry, we start with creating the certificate in the user database and sign the procedure. So far it's the same. So then there's a new step. We drop the private key. We can do this. Because, and the point of this is, say that the super user is looking over our shoulder and eavesdropping. That's the password. I'm going to use that to sign my own procedures. You can forget that, because the private key is gone. And without the private key, you can't sign. You can only use it for verification. Then the next, so that's the point of this. So the next step then is to copy the certificate, that is the public key, to the master database, and then create the login from the certificate and grant the login the required permissions. So let's have a look at this. So I'm going to move to perm test. I will start with creating this view in perm test as well, so I have it handy. And then I'm going to create a procedure called show sessions with the same content as before. Let's say that I'm a server level DBA thinks that, oh, okay, we're going to stick this in the user databases because Microsoft doesn't like we use unsupported things. But I still want to have a check that it's only the people I've put into the role super users who can do this, because I want to have control. So I'm going to do this, and perm to super tries to run this. But as you might guess, there is no signature present, so he only sees his own session. So then I go and create this certificate called daemon server cert2 with the password tomorrow never knows, with the subject for signing of perm test DBO show sessions. And I'm then signing it directly as signature to show sessions by certificate daemon server cert2 with the password tomorrow never knows. And then here comes the step of removing the private key, or the certificate daemon server cert2 remove private key. Private key gone because the private key has fulfilled its purpose. And then I'm going to copy the key to master, so I can do this. I can retrieve the public key with the function cert encoded, which accepts the ID for the certificates, which I can get with the function cert ID. Move over to master and say create certificate daemon server cert2 from binary equals at public key. That seems easy enough. But there is a snag. I get a syntax error near public key. Because, you can't have a variable here. You need to have a literal. You need to spell out your public key, which is a long blob. Don't ask me why they made this design. The only reasonable reason I can think of is that they were short on time and did not have the time to support or to implement support for variables. So I need to use dynamic SQL. So again, I retrieve the key with cert encoded, have an SQL variable, and then I form the command this way using convert varchar max with model 1 that gives me hex string. Prints out the command, print out the command, and move to master and run my SQL code. You see, this was the one I generated, and this time it runs without error. I can now create the login and grant that login the permissions needed. View server state. Move back to perm test and run this as perm test super. And now these two, we see the login and the certificate in sees login token, and he sees all sessions, except for the one in temp to be. The script continues with a second way of doing this, because create certificate from binary was introduced in SQL 2012. So if there are any poor souls who are still struggling with 2005 or 2008, you can use the other commands, backup certificate and create certificate from file. And the script shows this. I'm not going to spend time on it here, but if you want to look at it, you can do that. And if you're on SQL 2000, I'm sorry, none of this stuff works there. Bad news. So you might guess now that, this is also, we can do this, but yes, of course, we should automate this. So I've put a script for you. A script, not a stored procedure? Yeah, because I'm thinking this, let's say if you are a DBA and you're managing managed service, well then maybe, you might want to run this, do this operation on that server, that database on Monday, this server, this database on Wednesday, on Friday, it's that database over there. So it's much easier to have this on your disk. Just open it in the Management Studio where you need to use it. But if it would work better for you to have it as a stored procedure, feel free to change it. Now, so what the script does is, well, you need to specify the database, the procedure, and the permissions you want to package. And the script will then create the certificate in the user database, sign the procedure, drop the private key, copy the certificate, that is the public key, to the master, create the login from the certificate and grants permissions. And now, for some extra spice, let's say that the database is in availability group. Now you need to have the certificate, the login, and the permissions on all nodes in the AG, or else things will start to break after a failover. So this script takes care of this for you. It's going to set up a loop over all the nodes in the AG and set up a temporary linked server to do the copying. So you get that done. So let's have a look at this script, or rather the top of it. So here I specify the database, I specify the procedure. Here's my permissions. I don't need a table type since it's not a stored procedure. And there's also the debug bit. And here's also some queries so you can look at what has been created. I'm not going to look at the script because that's even more dynamic a skill. I'm just going to run it. And it prints out in which database things executed, so you can see that. And because all accesses to the database has to be dynamic SQL, we see the check here. Do we have any signature on this procedure by this particular name? Yeah, in that case, we're going to drop this signature, which is called sign perm test DBO show sessions with brackets and all. And the double quotes, in case you're not aware of, fills the same function as the brackets. But I'm using different delimiters, so I don't need to nest the brackets in the script. And this here I'm checking if there happens to be a user created with a certificate, so I can drop it. So I'm sure that I can drop the certificate. And then I'm gonna drop the certificate, and here I'm going to start over creating the certificate. And also you see the name convention is different, and the purpose of that is that, well, one reason is that I created this script many years before I created this procedure, but it's also good that it's a different convention so they don't clash, because sometimes you want to package both server level and database permissions, and that might be, if you have separation of duties, done by different people. And you can see here the password is the GUID with the subject grant server state. I add the signature, I drop the private key, I retrieve the public key, move to master, run the create certificate, create the login, and grant use server state. Now this database is not in an AG, so you don't see that part. If it would be, you would also see in which server, in which node it created the whole thing. So, now before I draw this to close, or rather the closing part about certificates, I'd like to talk what I think is the beauty of the whole thing. So imagine this, you are the server level DBA and you have, well, developers or power users or whatever, and they want to do something with server level permissions. Now, you can request to review their code before you sign it, before you give them the blessing with adding the certificate. And see, okay, yeah, this is what we agreed on. You have not overstepped the boundaries we agreed on. Now, if the power user or developer goes back to their desk and change the procedure, well, the signature and the permissions will disappear, go away. So they need to come back to you to have it reviewed again. That is, they can't cheat on you. They can't elevate their permissions behind your back. You have full control. Of course, you might be bogged down with work, so you might not even actually have the time to review the code. That's another challenge. But from a technical perspective, you have full control, which you may not have with the feature we're going to discuss right now. That is execute as, which is an alternative way to do the same thing. Let's first talk about to use this for database permissions. And there is a proper version to do this with a three-step recipe. That I first create a proxy user called, well, without login and with the name derived from the procedure. Grant that proxy user the minimum permissions needed for the task, and then add this clause with execute as sbname $proxy, or whatever I call the user, to the procedure. And in this case, you would always stick this in the deployment script. You would have to have it on top of the script because you can't create the procedure without this user being present. There is also a lazy version. Well, then you just only say, with execute as owner. That's all you need. That's the lazy version. Well, let's look at both. So I'm going to move to perm test. I'm going to create a new procedure. Well, it's a new name, Testproc, but it's the same thing as before, the version with the dynamic part. And rock and roll is going to get permission to run this one. And just as a recap, test user runs this into Norwegian Wood. But you see there is an error message on the dynamic part, but Norwegian Wood was inserted. So let's now apply the recipe. I create a user, testproc.proxy, without login, grant select on perm table to testproc.proxy. And then I go and alter the procedure, saying with execute as testproc.proxy, that's the one line I added, select from token info, and do the insert on the dynamic part, the same thing as before. And test user runs this and going to enter back in the USSR. And yes, there is no error message, so the whole thing worked. We could use the execute as thing to package the permission for the select into the table. But look here now, it says entered by testproc.proxy. And look at the tokens, it said testproc.proxy and public. And well, already login, that's me, system user, that is just a SID. And DB user, that's testproc.proxy. There's no sign of test user. So this is not just adding a token to this user token, adding permission. It is replacing them. Because this is impersonation. We're just not trying to play testproc.proxy. We are John Malkovich. So that's quite a bit of a difference. It works quite a different way. So it has some repercussions. So let's see what happens now if we try how this extends. We're going to recreate this trigger. And I'm going to do this version here, which calls SP help index, the inres P, and then fires the trigger. So let's see, if you might remember that when we did this with the certificates, when we entered the trigger and inres P, the token of the certificate user was removed. Now let's see what happens when we do this. Test user runs this and enters drive my car. And you see, it worked into SP help index. We could do that. So obviously, we were still testproc.proxy. And look here, in inres P, we are still testproc.proxy. Perm table tree, we are still testproc.proxy. Now imagine here that inres P is making some retrievals of, let's say, row level security based on, let's say, system user. Well, it's not going to return the correct results. It's going to return something completely different because the caller was invoked with execute as. Inres P does know nothing about that. Or let's say the trigger is doing some auditing based on system user. It's now going to auditing the completely wrong user. And here is the lazy version, the truncate. I'm going to do this with the truncate version. So I'm only saying with execute as user, with execute as owner, and this is the reset version. And create this one. And test user is now running this, entering with a little help from my friends. And indeed, with a little help from his friend DBO, test user was again able to clear the table. So look here, the tokens. DBO, public DB owner, system user, SA. Oh, bit scary, isn't it? So here we also, if you want to know, do I have any procedures that uses execute as? That's actually quite simple because in this SQL modules, there is a column, execute as principal ID, which is, well, the ID for that user or -2 if it's owner. So I can run this and see in this database, I have testproc execute as owner. So what can we say about this? Well, of course, there's no denial. This is simpler than certificates. It's lots less syntax. It's quite easy to do, particularly the lazy version. But first of all, the lazy version brings the principle of granting minimum permissions. And keep that, I forgot to, remember that part of bad dynamic SQL. Let's say I would put execute as owner on that procedure. Well, now the SQL injection could be used for doing anything in the database, dropping a table, adding the current user as a member of DB owner. So it's really, really bad. Also, as I hinted, if you have schemes for row-level security or auditing that is using system user, username, session user, there's a whole bunch of these functions. All of these, they're going to return the name of the impersonated user, the one in the execute as clause. So they will not give the correct result. Now, this is not a showstopper because there is still original login. Original login still, you might not notice that in the scripts, that still return my ID. So that reveals who actually logged in. And sometimes you might have application that is logging in and then impersonating the real user. But there is still more options. There is session context. You can set session context with, I think the function is, the procedure is sp set session context, and then you can retrieve it with the session context functions. This is SQL 2016 or later, but there's also context info in earlier versions. So you can do that. There's no problem. But you need to plan ahead. You need to design your database so you can use execute as. But if you just start going on, you find this in the Google post. Oh, this solves my problem. This solves my practical problem right now. The user can't do this, and then you break a whole lot more things. That's dangerous. And now you're just sitting a bit nervous. Wait a minute, we have system use on the database. What if any of my developers get this idea? So, well, I do have a solution for you. Down here, I'm not going to spend time on showing it, but there is a DDL trigger that is going to say, no execute as in this database. And really, if you're using system user or anything like that, I would recommend to do something like this, because I find it this a bit scary. But despite this, let's say now we think this still is simple, easy. We want to use this on server level as well, because certificates sound so difficult. So then maybe we think that, yeah, create a proxy login. We can disable that one so it can't log in. We can grant that login permissions, and then you add execute as clause. That sounds very simple. I'm going to do that. Well, let's try it. So you move to master, create a login called show sessions2 $proxy with a password of magical mystery tour, and which I'm then disabling, and then I'm granting this guy view server state. I move to perm test, and I create a user for this guy. And then I'm going to create show sessions2 with execute as show sessions2 $proxy. I'm going to check the login token info, and then, yeah, here is actually a thing that's a bit of a complication, because if I would do this check directly on server role member has perms by name, that would check the permissions of show sessions2 $proxy, which is wrong, but I can revert back to the caller with saying execute as caller to get the right context and do the permission check. So this part actually added a bit complexity. So let's try this procedure. I'm going to try this on my own first and run this. And what? I only see my own session. I'm sysadmin. What's going on here? Well, look here among the tokens. So we have public and show sessions2 $proxy. But look here, the usage says deny only. Deny only. Not grant or deny. What is going on? Well, you see, when you add execute as in a store procedure, that is the same thing as execute as user. And you might remember that I told you that execute user has some limitations. The thing is that when you do impersonate a user, that is only trusted inside the database, not on server level. So when you impersonate a database user, you are sandboxed into the current database, and you cannot access things outside that database unless two doors are open. The first thing is that the database must be set trustworthy. And the second door is that the database owner needs to be granted the permission authenticate server. Now you might recall that perm test is owned by SA. So that door is already open. We only need to set the database trustworthy. Well, let's try it. So we're going to move to master.
Erland, even if the SA is disabled, that will still happen?
Yeah. But you will still, always when you do execute as user. Yeah, and I know, yeah, because the database owner, yes, actually we'll see an example of this later on with a disabled login. We'll come to that, although it's not SA, but. So we're going to make the database trustworthy. Move over to perm test. I'm going to run this as myself first. And you see, and now I see all the sessions. And you can also see here that among the tokens, there is SA, SQL login, authenticator, and also new type of usage. And this means that this guy is now authenticating the other ones. If this guy has authenticate server, these here will be granted deny, else it will only be deny only. And perm test super runs this as well. Yeah, and it sees all sessions. So it may seem then that this is a whole lot simpler than the certificates. We can grasp this, we can understand. Watch out. Trustworthy is a security risk. First of all, keep in mind what we did with the certificates. Now, I said you can go back, and every time the power user goes and changes the procedure, you can review the code, request to review the code before you sign it again. But if you do execute as and trustworthy, well, you give the user the carte blanche to do everything with the procedure. You're basically granted that guy view server state just in a different way. Because now he can change the procedures, well, just remove the filter on DBID or go reading completely different. Or we can create new procedures with the same login. It's all they can do. But that's not all. Red alert, red alert. And for this, I'm not going to use execute as login, but for real effects, I'm going to actually log in as permtest super with the password of yesterday. So I'm logged in as permtest super. I'm running this query from login token info. And I'm also adding a check. Yeah, I'm a member of sysadmin. I'm not. But you can see here, permtest super, public super users, and original login is permtest super as well. Everyone is permtest super because now it's perfectly normal. But look here, I'm now saying execute as user equals DBO. And permtest super is sysadmin, token name, SA, public, sysadmin, and this guy is authenticator. And the system user is SA, DBO. So if all auditing now, which is on the system, which happens to be based on as system user, well, SA will get the blame, not permtest super. He might get away with it. And just to show you that it's not a joke, do SP configure here? Yes, I can do that. So, remember what I said, that it's not best practice to have SA as the database owner. So let's change that now. No. Sorry, I'm going to log in as myself now. So what I think is best practice is to have the database should be owned by an SQL login, not a Windows login, because that would be connected to a user who might leave the company, and then that causes all sorts of problems. And I guess that is why many people like to have SA as the database owner. No, a database should be owned by an SQL login that exists solely to own that database, and which does not have any permissions at all. So I'm going to do this. I'm going to create the login called permtest.owner, and because I really don't want to know the password, I'm not going to give it to Beatles song as password. I'm actually going to give it to Gwyd, and then I'm going to disable that login, and I'm going to make it the owner of permtest. Permtest.owner is the name. So I'm logging back in as permtest super, and he tries the DBO trick again, but he is not sysadmin. And you can see here, it says deny only, permtest.owner is authenticator, but there's no permissions. Unfortunately though, when he runs show sessions 2, yeah, he only sees his own session. So I said this guy should not be granted any permissions, but yeah, someone told me that if I grant authenticate server, that might solve the problem. Let's see if I do that. I'm going to grant authenticate server to permtest.owner. Oops. And he runs this one, and now he sees the sessions. This guy now is still authenticator, and because it has authenticate server, that's grant or deny. And then I'm going to run this as DBO. You can see it do this trick again. Oh, he's not sysadmin. That's great. So did we tighten the security hole, or wait a minute, something's going on. He's creating a user for me in his database. He can do that because he's DB owner. He can do anything in the database. And then he's impersonating me, and he is sysadmin again. You can't have your cake and eat it. So, if you make a database trustworthy and the database owner has authenticate server, this means that anyone in the database that has DB owner or, well, enough permissions to create and impersonate users can elevate to sysadmin. So that's not a kid's game. That's quite serious stuff. So the recommendation I gave you is that the owner of each database should be a unique SQL login that exists only to own that database and be granted no other permissions. And my thinking here is that, well, if someone tells you, oh, we need to make the database trustworthy, well, that sounds so, well, innocent, so you may be lured to do that. But if you then find that, oh, it still doesn't work, and someone tells you whatever you find, I need to grant permission, then wait a minute. Should I really do this? And particularly, he said this, one should not have any permission. So it gives you a second chance to think. Now, all this said, there are actually situations where this is sort of uncontroversial because there are lots of servers, lots of databases in this world where anyone who has permissions more than read and update data and tables, they are already sysadmin because there are no local power users. And of course, in that case, there is no security problem with Trustworthy. And of course, you should be very sure that it's never going to change. What if you bring in a consultant? Something's going to change over the years. So you can use it, but you need to understand what you're doing. So I will give a very quick, and this will be very quick, overview how to do this for cross-database access. So let's say this, we have a database A. There is a procedure P that accesses table T in database B. Now, by default, there is no ownership chaining across databases. So if you don't do nothing at all, well, that will be a permission error. Now, how to address with this? Well, there's so many reasons we do cross-database access. It could be a quite different pattern. It could be a database that for some reason, application that for some reasons uses multiple databases. I've seen that. It might be legacy reasons, whatever. Or it could be that it's two different applications, but they need to exchange data in a few places. And there are quite a few more possible patterns I can think of. So what is actually the best solution depends on the situation. I'm just going to go in a quick overview what you can do. So, well, one is to raise the white flag. Okay, we're going to add the users to B and grant them permissions on T. And sometimes that is not a problem for various reasons, but not always. We can enable cross-database ownership chaining and we need to do it as for both databases. It's called auto-database DB chaining. It requires sysadmin. And if you do this, well, then it works just, and the databases need to have the same owner. Then it's going to work just like in the simple database case. But you still have to add the users to B, but if it's a multi-database application, then it's going to work out. There is one big problem here, though. Exactly the same thing as with Trustworthy. That is users with, well, sufficient permissions in the database, DB owner or at least elevate permissions to create procedures and users, etc., can elevate to sysadmin. It's more cumbersome to exploit because it requires setting up an agent job, etc. But it's not going to stop a rogue user. So be very, very careful with this. It's difficult to recommend, but if you know that, for example, but there's no one who can elevate that, then you might use it. Certificates, that's a perfect solution in the case where you have just these occasional accesses, not on a broader scope. What you do in this case, in this example, you would create the certificate in B, create the user, and grant the permission on T, copy the certificate, both public and private key, and sign P. And, well, you will also drop the private key. And now, the cool thing here is that you don't need to add users to B in this case. And let's say these A and B, they could have different power users that don't really trust each other and should not trust each other. They can still sort this out without involving the DBA. We also have execute as and Trustworthy, which can actually be a solution for multi-database applications. I would say, I think it's a better alternative than enabling cross-database chaining if done right. That is, first of all, the database owners should have to be owned by the same SQL login with no permissions. So that's a little bit different from what I said before. And also, it must be the same set of people that are DB owner in all databases. If you split up the databases for security reasons, because different people is going to administer different parts, you cannot use execute as, because then you have the same elevation problem as before. Now, this is something I discuss in a whole lot more detail in my article. There's a longer chapter about this. Still probably quite confusing because, as I said, there's so many variations. If you want to do this, you really have to think what is the best for you. So I'm going towards the end, going to do a quick recap. So ownership chaining, well, that's what we use, let's say 95% of the time for the plain, simple, and email procedures. We have been using it for years. We may not have been aware of it, but we have been using it. But it does not work with dynamic SQL. It does not work with advanced permissions. It does not work with metadata access. And it does not work with server-level permissions, and by default, also not cross-database access. We have certificate signing, which I think is an excellent method to package about any database or server-level permission in a stored procedure. Very fine-grained. I can find exactly the permissions I need and doing exactly this. It may seem like a hassle first, but once you automate it with these procedure, the script that I show you, it's quite easy to manage. I only show it for the cross-database example. You could do that with scripts as well, but automate that. But I think for doing that for a multi-database application with cross-course all over the place, it would probably get out of hand. And I would say this is the preferred method to package database permissions. And I would say always use this when you want to package server-level permissions. And execute as, well, it's good for the lazy and casual. I will have to say that. But it has implications for auditing, row-level security, that you need to plan ahead for. So much for being casual. You really, to be casual, you first have to be, well, forward-looking. But I can't say I like execute as, but I would say it's still okay to use it for database permissions if, well, conditions are, well, relaxed. But for server-level permissions, now, use certificates. This trustworthy business is just, you will have to understand very well what you're doing to do this. So you don't run into a problem if you use certificates. So this is getting very near the end. Our slides and scripts. My name is Erland Sommarskog. My email address is there if you want to reach me, if you have questions about this presentation. Of course, if you see me during the rest of the week, please feel free to harass me. I really talk to users while I'm here. Really fun. And you find slides and scripts on the PASS website and on my website, sommarskog.ec/present. And there's also, here's the URL to the article this is drawn from. There's also an appendix. The article itself is quite long. It's like 70 pages, but that is partly because I do add some more material, but also because I do explain things in a quite slower pace, I like to believe. And the appendix then covers special applications, for example, activation procedures for service broker, for example, which is a bit special. And if you run this script on your own, down here, there's a cleanup script you can run to clean up your instance when you're done with it. And I have a plea for you. Please, please, please fill in your session evaluations. So I know, PASS know, whether I did good or bad. So PASS know whether they should even consider me for the next year, or if I should even consider to submit next year, and so on. And there are 3 ways you can do that. And yeah. But like that, I would like to thank you for attending. Have a good day of PASS. And be aware of trustworthy. And of course, if you have more questions, there are a few more minutes left so we can. I see you, yeah?
So, if I have a scenario where I want to achieve row-level security in SQL 24 teams, so
Yeah.
operators there, would it be possible to go along with certificates and do the executors caller there, or is this kind of?
Well, so the row-level security is usually based on seeing how the current user. First of all, it depends on how you implement your filter. But usually that looks at something like system user already a login or context info, something like that. So, and why would you use a certificate to override the row-level filtering? That's a little strange for me to say. Then you would have to be very. Of course, there could be a scenario where this could make sense, but I'm not really sure that I see it on the top of my head. Many of these things you can do is sort of, this is the method. Then you have to figure out how would I actually use this in this particular case. And that can take some time to figure out for the more advanced cases.
So this is the classical use case for
Execute as, well, but if you wouldn't use execute as with row-level security, because then you're breaking the whole thing, unless if you implement it on system user.
That's what I have to talk about.
Yeah. Yeah?
So the certificate access method, is that going to work for sysadmin level limited scope permissions, like, for example, changing agent jobs? That's one that's going to be fairly often.
Yeah, so yeah, I didn't talk about doing things in MSDB because to keep things simple. But yes, you can package. What you can do, you can add the certificate login to sysadmin. You can do that. But there might also be restricted permissions in, let's say, agent. I do have in the appendix. I do have a chapter where I talk about letting users start a specific job, and I got some variations of to do that. Agent is a big, because the problem with the agent procedures is that they are not system procedures in this model, so that makes things a little bit difficult. I skipped over that because, well, I only have 75 minutes. But I do. The example I have there, is for starting jobs, but so that could also give some ideas how you can do this more civilized way. But yes, you can always cop out with adding the certificate login to sysadmin and having control of what you're doing. But again, only do that sysadmin if you really need to. If you can.
Yeah, it's just for changing owners on single agent jobs, which requires sysadmin access.
Yeah, but if you want, for example, users to be able to take ownership of a job, and you have some control mechanism in that procedure, okay, this user make control of that job, you could sign that with a certificate, and the certificate login is member of sysadmin. Okay. But then what happens though if when you run the other if you then invoke procedures in MSDB, it's a little tricky because then the certificate that will not proceed into those guys. So I think so you might have to look at that chapter and see what you can do, because you can do it with counter signatures, but that's a little iffy because then you have to sign the procedures in MSDB. But you can look at that chapter. It's not exactly the use case you're looking for, but it's working with MSDB. Okay. And if you have questions, please feel free to mail me.
Thank you.
Yeah.
I've done the signing of store procedures using a sysadmin, because full text search requires sysadmin to go through the parser. Are there any other security holes by signing and creating a certificate with sysadmin?
Well, the problem is if you, I mean, the main problem is, I say, if you're using dynamic SQL and you have managed to create yourself a SQL injection hole. So you have to be sure that you're not.
It wasn't dynamic, it was querying the FTS parser.
Yeah, that's one. That's one really doesn't. I would expect.
Sysadmin.
Okay, I would expect to use server state, but I could be wrong. So yeah. Well, my time is out, but if you might come up and ask to talk with me, or we can. The break is long, so we. Yeah.